Hello, welcome back to BIMvoice. Today we are going to talk to David Robinson, who will talk about BIM for electricians, for electrical stuff, something that unfortunately we don't talk too much in general. Welcome, David.
Thank you. Glad to be on the podcast today.
Very happy to have you here. Please tell us a few words about yourself and then let's hear your story.
Yeah, so my dad actually was an electrical engineer. So he had an MEP firm out in Seattle, Washington. So that's how I got involved in all of this. And so in the mid 90s, actually, I was helping his engineering firm write software for AutoCAD at the time because BIM didn't exist in the mid 90s. So we're trying to write software to help automate the design for electrical engineers. In about 2001, our software got to a point where we felt it would be useful for other people. So we made a company called Design Master, and we started selling software in 2001 to MEP engineers, electrical and mechanical. So we've been doing that for the last 20 years, originally on top of AutoCAD. So we were building electrical software there. And then more recently, we've been doing stuff in Revit for the electrical side. So I've been doing, CAD stuff for my entire life. I've been doing BIM for as long as BIM has existed. So that's my background. That's how I got into this. And that's what I'm doing right now. I'm developing software for electrical engineers.
Also, you are developing software.
Yeah, correct. So my background is, again, not electrical engineering per se. My dad knew all of that. So I know quite a bit of electrical engineering. I kind of, picked that up in the womb, so to speak. So I know all of that, but my background then is on the software development side. I have a degree in computer science. I run a software company at this point. So I know enough about the electrical engineering, but I'm not doing the design myself. I'm writing the software for my customers to then go out and do that design.
Okay, go ahead. Tell your story.
Yeah, so we focused on the BIM for the electrical engineers, that when you start looking at what was done with BIM and what has been done with BIM, it's always this fancy 3D model that the architects are going to use, which is the right place to start. They're the people who are going to be doing the building. But then you start getting over to the electrical side, and it starts to not be as useful because architects are very visual. And so they're thinking about the 3D modeling. And on the electrical side, that's the last thing on their mind. An electrical engineer, they don't care about the 3D at all. They could do nothing in 3D and be totally happy and fine and get the vast majority of their buildings done. They're thinking about things like, how big is my wire? And that wire is, very, very tiny. And what type of breaker am I putting in? And that's the breaker that's going in this big box that's a panel. So that breaker needs to be modeled properly, but that's not really a whole lot of 3D. It's more the information side of building information modeling. So the electricals need a model that's not 3D, but is focused on what the electricals are thinking about their pieces. And it's different than what an architect needs.
So can that information be put in the 3D, or do you think it's better to keep it in another way?
So the goal would be to have it in the 3D model, not necessarily because you want it in 3D, but because you want that single building model. The goal of the industry is single building modeling, where you have one model with everything in it. Electrical engineers really thinking kind of three models. When they start their design, they have what's called a single line diagram. That's where you're laying out your panels and your transformers, connecting them. That's very diagrammatic. And so there's no 3D modeling. Half the time, you don't even have an electrical room yet. So they're not laying stuff out, but they're thinking about the pieces that they need to have. Then they also have the calculation portion, which is where they're sizing their wires. They're calculating voltage drop, doing all that calculation stuff. That's really kind of the bread and butter where they're adding the most value. And then finally, you have the construction documents, your Revit model, whatever that is, where you actually, you are laying stuff out. So you've got these three different pieces, and generally those are three separate pieces. So you really have three different models happening. You make a change in one, you have to go make a change in the other. And so there's a whole lot of coordination they have to do internally. What we're trying to do with our software is bring those three pieces together, essentially in Revit, because that's kind of the common platform, and that's the best spot to work in. So you pull your single line into Revit, you pull your calculations into Revit, so that all of those changes are happening in one spot. Not because necessarily you need the 3D in Revit, but that's just kind of the right platform to be building on for this purpose.
Yeah. This is for the design part, right?
Yes.
How is that information read on a end user on the site, for example? Is it possible to access it, to read this information in a way from, I don't know, from a common data environment or something like that? Or how do you get it out from Revit?
Well, I mean, you get it out kind of in the ways you've been getting out 20 and 30 years ago. Eventually, you have construction documents that, you know, you have to take to your plan reviewer and he has to sign off on. So that's the final deliverable. You could, in theory, be working from the Revit model, but that requires everyone to be looking at the same information and have that software. So really, eventually, you end up on paper with your documents or your, I guess, PDFs at this point a lot of the time. But like we do our calculations, and so you'll do a voltage drop calculation. So you'll notate that on your single line diagram with some information. Here's my single line. Here's how things are laid out. Here's the voltage drop on my feeders, and then the plan reviewer can check off and make sure that those are all correct. So the information is living in the model that's being output essentially as PDFs.
Okay. But this platform, your platform, what is the name of it? How it's called?
So yeah, so our software is Design Master Electrical RT. So that's our specifically for Revit, our electrical software.
And it's like a plugin on Revit, or how
and
it
so
works?
It's a plugin. It runs inside of Revit. The idea is that you're working inside of Revit. You're not having to go outside to Excel or some other third-party program. You're working in Revit, you know, kind of layered on top, but not having to move outside of it. That keeps everything inside of Revit. And we make sure that, you know, again, you're asking about how we get this information out. We do all our output as shared parameters, which is kind of getting into the weeds of Revit, but we use like standard Revit functionality so that someone else who doesn't have our software can still open up our model and actually see all of the output. So if that information is being shared, it's still visible to all, you know, people involved in the process. It's easier to change using our software, but the output is still visible to everybody.
You said shared parameters. I guess maybe in the US, unfortunately, it's not so popular yet, but in Europe, this becomes the norm, in Norway at least. And there should be a way, I guess, to convey that information from the shared parameters, maybe mapping it to an export to IFC if necessary. This maybe it's not designed with this in mind, but I don't know, maybe we should start, I should dial back a bit and ask, what is actually the state? Because this is the topic of my podcast, right? OpenBIM. Do you see any traction for IFC or OpenBIM in the US?
So I have seen IFC used as a transfer format for essentially 3D stuff. But on the electrical side, when you start digging into IFC, all the interesting stuff we're doing, there's no place to put it in the IFC model. That they just don't think about these sorts of things. So they haven't fleshed out an electrical model in a way that we have, because we're thinking like it's largely driven by architects and probably contractors, and they're not thinking about electrical design. So they don't have a place where you can put in the specific breaker settings that you need, or just, you know, I don't know what IFC has specifically because I haven't looked at it recently, but, you know, something like Revit doesn't have a transformer size. Transformers are sized in kVA. It's like a very basic thing that you have for a transformer. Revit doesn't have that implemented. I don't know if IFC has that, or there's other things like that where they just don't even have a spot to put our information. So we've got all this great stuff, and there's just nowhere to put it. So IFC kind of becomes like you can do a 3D output, you can do collision detection, but in terms of like the modeling, the higher level, all the non-3D stuff that's going on with electrical, there's nowhere to put that information.
I cannot contradict you on that, because unfortunately I'm guilty myself. I did not work too much with electrical stuff, and it's it's a small part of the project. It's as important as every other discipline. I'm not like, everything is very important. You cannot have a functional building if you don't have all the disciplines. But I mean, like, the budget and the cost of this, it's less, right? And then you get less focus on the features and the development as well, unfortunately. So what I will try to say here is that I don't know too much that part about electrical stuff in the IFC schema, but I would argue, since the IFC schema is improving from version to version, like now the aim is to spread it to infrastructure and so on, I would guess maybe sometime in IFC, I don't know, 4.4 or 5, maybe we get more attention to this complementary or these other disciplines that are not so huge chunk of the pie of the entire project, you know?
Yeah, and that's really just kind of the history of how BIM typically works. Is you kind of start, you get the architectural super fleshed out, and then you do fill in with the other disciplines that are smaller. And it totally makes sense that you would do those last, because like architect or electrical design is a very small portion of the entire building budget, so it's just not going to get that attention. But to be, so it does, but it does eventually need to get filled out, and so hopefully that's happening. That's what we're trying to do on just like the first level BIM side in Revit, just actually give some attention to that, because we're a smaller company, so we can focus very specifically on this smaller niche.
I understand.
Because again, we're also just thinking about electrical design and not even on the electrical construction side, because that's a whole other thing. Because when you're doing construction, you have different concerns on the electrical design, because then they are starting to think about, okay, how are my, conduits going to be laid out? You're thinking about things like prefab that you don't want to have to think about on the design side. So we're working with some integrations to transfer our data, transfer our conduit sizes, because that's like the most important relevant 3D thing over to the construction side, but not trying to like make a all-in-one electrical package, because the contractors need something different from the designers.
Okay. How an electrical designer would benefit of this tool of yours? How will their workflow improve? And what will be the benefits of using it?
Yeah, so right now, like I said, they really have 3 separate models. They've got their single line diagram that they're drafting by hand in a drafting view, maybe even AutoCAD. They've got their calculations, which are in Excel spreadsheets, maybe in a third-party tool like SKM or EasyPower, which they would know about. And then you've got your Revit model. But they're 3 separate pieces. And so you make a change in one, and you have to go back and make the change in the other. Obviously not an ideal workflow. We are bringing those 3 things together, essentially pulling the single line in the calculations into Revit. So you have a single model in Revit. You're drafting our the single line diagram in Revit, but it's linked to everything else. So you change a panel name, and it changes in the single line diagram and the Revit model, like you'd like it to. You move a panel, and that changes a wire length. That updates your calculations automatically, because that has implications for voltage drop and short circuit analysis. So all those calculations come together in a single place in Revit, rather than having 3 separate pieces.
Is this a product specially built just for the US market, or can this be used by other companies in other places? Like, I'm thinking regarding standards.
So obviously we're based in the US. It's focused on the US market. However, physics is universal. So it does translate to the other markets, but then you do have to think about the things that aren't universal, which are the standards. So you have things like wire sizes, and those are going to be different. We have customization built into the software to be able to account for that. There's the 50 hertz versus 60 hertz difference in electrical systems. That's, again, just a change in some of our customization settings. So you can use it in other markets pretty successfully. We have companies doing that. And then Revit itself actually does a lot of the heavy lifting, because a lot of the stuff, like different ways panel schedules are laid out, Autodesk has actually spent some time localizing that to the different markets. So we get to benefit from that. We're not having to do that work. We're focused more on the calculation side. And as long as you get the settings right for, your wire sizes or your impedances and whatnot, that does work out between different countries and different areas.
That's good. Outside US, do you have more clients from Europe or Asia or other places?
I've got a smattering in Europe is really where I have it, is where I've seen it. So it's largely US, Canada, and then a handful in Europe is where we've been able to sell at this point. I would happily sell to other markets.
Yeah. But how big is the company? What can you tell me about the company?
So the company is not big. We are old, though. So we've been around since 2001. So we've been doing this for quite some time. At this point, we have 5 people at the company. So it's a small company, but we're, again, focused on a very small niche. So it works out. And we are self-funded. So we grew out of our own design. My dad's basically engineering firm funded our development originally. And so we are self-funded and are able to work at this smaller scale.
Yeah, that makes sense. Not all the companies needs to be big. It's good. We need more entrepreneurs. and solutions to our problems. That's good to hear. From your experience so far, since you built this product, can you tell us a bit about some success stories you had?
Success stories using the software itself.
Yes.
So for success stories, we work with engineers all over, essentially the United States is largely where we're focused. And it's never like these huge projects necessarily that they're working on, but it's just they're working on lots of smaller projects. And so we do review with our customers how they're doing. And we've talked to some customers. There's one customer, Brian Zapp, he's down in Florida. So he's a one-man shop, and he's doing his projects in Revit. And he told us that based upon using the software, he's seen his design times cut in half. So
Wow.
he's seen, that's a huge improvement. And for a one-man shop to be doing that is just huge. So I don't have any like huge like projects he's working on. He's a one-man shop. He's working on smaller stuff, but he sees huge time improvements using the software.
Yeah, that's good to hear. But are there any limitations for larger teams, or is not the issue the team size?
Team size is not an issue. We leverage BIM 360. So if Autodesk has kind of solved the multi-user problem. So we have larger companies who are using it too. There's a contractor, Sprig, who's out in California. They have 10 or 15 people using it, and they're using it on large projects, have multiple people working together. So it works just fine on large projects. It scales as well as Revit scales, and Revit struggles with large projects at times. But we do just as well. So we keep up with what Revit's doing on the large projects. So there's no limitations on our software for the sizes.
It's something you download and you install in Revit, right?
Yeah, so it's a download. It's essentially desktop software. It's running on your computer inside of Revit. So you download it, you install it, it runs inside of Revit, it adds a new little ribbon, and all our commands end up in there. It's kind of a functionality for how that works.
Okay. Do you have any documentation on this? Does the product has good documentation? Do you have tutorials or something? Or how do people learn how to use this tool?
For learning the tool, we have a set of tutorials on our website, and that's kind of where we have people go is to learn it. And then from there, we do kind of white glove onboarding for each customer. You go through the tutorial, and then we walk you through, because every company is a little different in how they're using Revit, the projects they have. So we go through those. We also do a monthly webinar where we do training, and then those trainings are available. So we have a good library of trainings, kind of going into the depths of the software, because some of the stuff we're getting into like very specific, very detailed engineering calculations. So we need to talk about how do you do an arc flash calculation in our software. So we've got a good training on that we can send to people. So we spend a lot of time making sure that we've got good tutorials, good user manuals, good training available.
I understand. What about support? Do you provide any support to people if they need more than tutorials?
So the support is included with the purchase of the software. We sell a subscription like everyone else does these days. And the subscription does include all the support that you need. Generally, the limit on our support is that people need to get jobs done, and so they have to stop asking questions at some point. But we make sure that when people call, they're getting us as support. So they're getting people who really know electrical design, because this is very technical software doing very technical calculations. So you need someone who knows something about electrical. You can't, that's the trouble with even writing software like this. You have to understand electrical. And so that's the
you cannot have me there.
Exactly. You can't just have someone who knows Revit answer a question about a voltage drop calculation. So we make sure that our staff is well trained on all the calculations and everything that's going on, so that when people call and ask us a question, they get an answer and can get their project moving forward.
Okay. That sounds good. How can people find your product? Where should they look for?
If they want to learn more, they can go to our website, to designmaster.biz, B-I-Z. That's our website. They can go there. They can learn about the software. They can download a free trial. We also run a webinar where I talk about creating single line diagrams in Revit. So for the electrical engineers out there who want to know more about what we've learned and kind of the frameworks we have for doing that, they can attend my webinar, and I'd be happy to talk with them about that and show that to them.
Awesome. That sounds very good. And again, this is for only for electrical engineers, or there any other kind of electrical technicians who can use it? Or
Correct. This is for electrical engineers, for the electrical guys doing the design work. We're very hyper focused on that niche and not doing anything else, trying to serve them as best we can. And we haven't branched out into anything else on the Revit side.
Yeah, I understand. Yeah, that makes sense. Well, David, thank you very much for sharing these thoughts with me. It was cool to find out more about the electrical discipline. And I wish you good luck
All right.
with spreading the wings of your product.
Thanks for having me on the podcast. This was fun.
Thank you.